Okay, so this is the third of this particular series under the first item of our AI learning series. And this topic is AI smart, or does it just appear to be smart? So in the past two segments of this videos, I talked about, what is AI, kind of how does AI work, and now we're going to talk about, is it smart, and can it be trusted? It's kind of a big issue. So let's see if we can get this thing to advance. So there we go. So from our last episode, I put this little chart up. This chart is a little bit old now, but still just points out this idea that in many dimensions, AI has already passed human intelligence. And so I think on an individual basis, it certainly has, because it has the ability to absorb vast amounts of knowledge in a relatively short time. And so, are they smart? The fact that these models can perform better on some types of standardized testings or other metrics, does that mean that they're smart? And how do they get to be so smart? All right, so we talked about this idea of training in the last video, where we have a corpus that is pre-processed, tokenized, embedded, positionally encoded. It goes through some networks, feed-forward networks, attention mechanism, things like that. Then has an output that we inspect, and then we backpropagate. So basically, we then adjust the network so that it will learn the patterns in whatever it is contained in the corpus there. So I want to talk a little bit more about this idea of the corpus and what's included in the corpus. So it's the AI model training data, and one of the most common corpuses, or corpi, I guess, is the Common Crawl. And the Common Crawl contains billions of publicly accessible web pages. It contains text from these pages and web HTML markup. That another example of something that would be contained in that would be Wikipedia. Now, Wikipedia is actually a pretty credible source of information because it's community edited, meaning anybody can come in and make corrections in Wikipedia, and as a result, it's has a better chance of being truthful and relatively unbiased than just regular posts that people put on the internet of different types. And it contains, in English, it contains over 7 million articles, and in other languages, many, many more articles. There's also, in Common Crawl, again, any publicly available websites are candidates for being included in this Common Crawl, the training data, this training corpus. Church websites for our church, Church of Jesus Christ of Latter-day Saints, or even other churches. And so, the scriptures and all kinds of things would be included in that. So this is a great thing because we have reason to believe that the corpus that we use to train these large language models actually has a lot of good elements to it. But unfortunately, also there can be some problems. So in 2021, so this is a little while ago, but some researchers actually did a study, and they looked at about 1% of the Common Crawl at the time and analyzed what it actually contained. And they found hate speech existed in about between 4 to 6% of the websites, which seems like quite a lot. Sexually explicit content in 2.36% of the websites that were in the Common Crawl, and violence was there, and then biased discourse, of course. You can imagine how much biased discourse is just published out on the internet. And so the Common Crawl contains a lot of good, but also a lot of bad things, including biases and inaccuracies and such. All right, so how might we clean up the data so that it can be more credible, so we can get better reasoning coming out of the large language model, better prediction of tokens? One I mentioned in the last segment is reinforcement learning by human feedback. And that basically means that these companies hire people, often in other countries. They hire people to basically come in and label data according to what it is. So for image data, it would be, this is a picture of a car, or this is a picture of a dog, or whatever. For textual data, it's like, identifying things that are accurate or inaccurate, and labeling this data, meaning tell what kind of data it is so that can be used to fine-tune the large language models. or even multimodal models for that matter. Another thing that we use to clean up data is moderation filters that actually detect when there are problems, usually things like NSFW, not safe for work, but not necessarily falsehoods. So the moderation filters, I don't know of any that are designed specifically to be detectors of truth. So we have to have other ways to do that I'll talk about in just a little bit. All right, so what do AI models do? We've talked about this before, the stochastic parent. They predict the next token, given whatever prompt and whatever context we put into the model, based on the training data so that it makes sense. So it predicts the next words so that they make sense, grammatically particularly, but also make sense logically. Whether it or not it is true. So in predicting, there's really no specific filter in there that says, oh, we only predict things that are true. So it could predict something that makes a lot of sense, but it's just not true. I had this discussion in October of 2025 with a GPT model, their open source OSS model that OpenAI distributed. And here was my conversation that I had with the model. I said, what is blue mixed with yellow? And the large language model responded, when you mix the primary colors, blue and yellow, you get a secondary color, orange. Blue plus yellow results in orange. Whoa. And when I saw that, I first thought, is that true? I don't think that's true. And so then I countered this with, I should have said I'm pretty sure blue plus yellow is green. That's what I thought. And the model responded, you're thinking the opposite direction? If you're seeing green, something else must be going on. Meaning I have some kind of problem. Now, I have to confess that it was so convincing in trying to tell me that blue plus yellow is orange that I started thinking, I don't know why I was thinking green. And I actually went to another model and I said, I think I went to probably Gemini, and I said, what is blue plus yellow? And it said, of course it's green. And I thought, how was I so close to being deceived there? So, all right, so that's an example of a hallucination. Over the years, I've seen all kinds of other hallucinations where the model just says something that I know is wrong, but it says it with tremendous confidence here. So the original question of this video is, do these models actually think? And what does that mean that they think? They don't really think. What they do is predict tokens to make sense. And they predict tokens that match some pattern, and sometimes they get the patterns confused. I'm actually very curious why this particular model kept thinking that blue plus yellow is orange. All right, so we get warnings when you use any of these publicly available large language models, GPT models, for example. They can make mistakes, check important information. They always tell you this. This is the Claude models. Claude can make mistakes. Please double check your responses. Gemini does the same thing. They warn us about this, and we often ignore those warnings. But I think that could be to our own peril if we ignore those warnings. Here's an image I made using Gemini's image generation model. And the caution is, we might be drinking or reading things that we get from a large language model, not realizing somewhere upstream there's some pretty filthy stuff being dumped into the river here. So the river here symbolically represents the flow of knowledge and information. And we're drinking from this if it's coming out of the large language models, but it could be polluted upstream, meaning there could be bad data going into the training sets or whatever that's causing problems. So, it's a word of caution. How can we help assure the truth as we head into mists of darkness here? What can we hold on to that will help make sure that the large language models or other models, AI models that we're using, are giving us truth? One is, I like using multiple models. In fact, I have different models they use for different purposes, but sometimes you put something into one model and then see how it responds and then have it be critiqued by a completely different model, hoping that maybe the biases are not perfectly aligned, that if there is some type of unacceptable bias in the models, that one or the other of the models would identify that and correct it. So that's one thing we can do. Another one is require sources. Some of the models do this by default, but some don't. And so I always like to say, hey, if you're going to tell me something, I want you to tell me where you got that information from. Give me a link to some website. And interestingly, oddly, more often than not, when I go look up that website, I think, well, that's not a very credible source. And I'm kind of underwhelmed by, again, the models, they just go out and search for information for context or even in the training, but particularly for the context. They go search for information without really qualifying, is this from a credible source? Provide truthful context. So one of the best ways you can assure that you get good reasoning and good thought coming out of your models is give them good input. And the way you do that is you feed in the context window, which I'm not going to go in details now, but basically you feed into the model with your prompt sources of information that are accurate, that are known to be truthful. And if you do that, the model will do a lot better job of predicting the next tokens that they will also be truthful. Use reasoning models. When reasoning models became popular in early 2025, the quality of the outputs went up significantly because the models that don't do any reasoning, they just hop right into an inference and conclusions that often have problems with them. So reasoning models can help with that. They cost a little bit more, they take more time, but that's what we do this for. So anything that requires, accuracy and requires, well thought out responses, it's good to use reasoning models. Finally, it's good to keep the human in the loop. These days, it's all the rage to talk about agentic workflows where we turn it over to the AI model and let it just go do things on its own based on instructions we've given it without ever checking back. And I just think that's problematic. I've even noticed in my Vibe coding, where I'm using the AI to do coding for me, I've gotten lazy. I used to check the code and make sure that the AI models were creating good computer code, and sometimes I don't do that, although I did some earlier today, and I looked at it and I thought I was actually kind of surprised at what it did, but it actually worked, and so it was fine. But the idea of human in the loop is that even if we're using agentic workflows, that we have junctures, we have key milestones where we have to have a human, ourselves or somebody else, basically check the work that the AI models are doing just to make sure that they are staying on track with reasonableness. That's all we have for now, so we'll have at least one more video in this series about responsible AI, and we'll see you next time.